Bismillah. Now number 16. Speak.
Dan either walks or cycles to school. The probability that he cycles to school is 1 over 3. Write down the probability that Dan walks to school.
Yes. So, how to find?
The total of the probabilities is 1, so we do 1 minus 1 over 3, which is 2 over 3.
Yes. So the probability to walk 2 over 3. Now,
when Dan cycles to school, the probability that he is late is 1 over 8. When Dan walks to school, the probability that he is late is 3 over 8. Complete the tree diagram.
okay. So, when Dan cycles to school, the probability to be late is 1 over 8. So, not late.
7 over 8.
Yes. 7 over 8 because 1 minus 1 over 8. Now, the probability to walk
2 over 3.
2 over 3 we did before. 2 over 3. So 2 over 3. If he walks, the probability to be late 3 over 8. So not late
5 over 8.
5 over 8. So 5 over 8. Now complete the tree diagram. Okay. Calculate the probability that Dan cycles to school and is late. Cycles and late. Cycles and late.
So it's 1 over 3 multiplied by 7 over 8, which is equal.
Wait. Cycles and late. Cycles and late. This branch.
Oh, 1 over 3 multiplied by 1 over 8.
So 1 over 3 times 1 over 8.
Which is 1 over 24.
Yes, 1 over 24. Now the probability that Dan is not late. Dan is not late in 2 branches. In this branch and that one. So cycles and not late, walks and not late. Okay? When we go along the tree diagram, so multiply to find this probability and also multiply to find that one, then add both.
Yes, sir.
Okay? So 1 over 3 times 7 over 8. This means cycles and not late plus 2 over 3 and 5 over 8. So times 5 over 8. So what is the answer? So 17 over 24. Number 17, can you read?
Hattie has a box of colored pens. She takes a pen at random from the box. The probability that she takes a red pen is 0.4. Work out the probability that she does not take a red pen.
Okay. Does not take a red pen. Probability for red, 0.4. So not red.
0.6.
1 minus 0.4, which is 0.6. Okay. The box contains only blue, red, and green. There are 15 blue and 15 green pens. 15 blue pens and 15 green pens. So same number of blue and green pens. Okay? Complete the table. So how to find the probability for blue and green?
The probability for blue and green is 0.3.
Each one 0.3 because 0.6 for both. Because the sum of all probabilities should be 1. The sum of all probabilities should be 1. Probability of blue and the probability of red and the probability of green should be 1. Now we have this 0.4. So blue and green 0.6 together. So if we divide by 2, so 0.3 for blue and 0.3 for green. Okay? Now how to find the number of red pens?
We can cross multiply.
Yes, we can use cross multiply because for blue, 15 pens and the probability 0.3. For red, how many pens for probability 0.4? And then cross multiply to find the number. So 15 times 0.4 divide 0.3. What is the answer?
20.
So 20. 18. Okay. Read number 18.
flu epidemic, 45% of people have a sore throat. If a person has a sore throat, the probability of not having flu is 0.4. If a person does not have a sore throat, the probability of having flu is 0.2. Calculate the probability that a person chosen at random has flu.
Okay, we need to complete the tree diagram first. If this branch 0.45, what about that one?
0.55.
Because 1 minus 0.45, so 0.55. Same. If this 0.4, how to find that one?
It's 0.6 because 1 minus 0.4.
Yes, 0.6. Next.
It's 1 minus 0.2, so it's 0.8.
Okay. Now we need to find the probability that a person chosen at random has flu. Has flu. So we have this branch and that branch. So what is the answer? Can you tell me the working first?
It's 0.45 times 0.6.
0.45 times 0.6. Then
Plus 0.55 times 0.2.
0.55 times 0.2. Yes, what is the answer?
So it's 0.38.
0.38. Number 19. Go ahead.
In this part, you may use this Venn diagram to help you answer the questions. In a class of 30 students, 25 students study French, F, 18 study Spanish, S. One student does not study French or Spanish. Find the number of students who study French and Spanish.
I need this number at the middle. We don't know what is this number, so we can consider this number x. Am I right?
Yes, sir.
The number of students for French, 25 students study French. So if this x, so this is the rest of 25, so this is 25 minus x. So 25 minus x. And we have 18 study Spanish. X, if this region has x students, so the rest of 18 minus x. And we have one student doesn't study French or Spanish. So we have one student outside because doesn't study French or Spanish. And the total 30. Now this means the students in this region and that region, all of them is 30. So if we add all, we get 30. Okay? Now we can write equation to solve for x to find this number. To add all and equate by 30, add the number first, 25 plus 18, 43 plus 1, 44. So 44. Now add x, negative x plus x, 0 plus negative x, so negative x. This is the total for all. This should be equal 30. So this equal 30. Now you can solve for x. Transpose x to the other side and 30 to the left hand side. So x equal 14. So the number of students study French and Spanish at the same time, 14. Okay? Now next one. Double I.
One of the 30 students is chosen at random. Find the probability that this student studies French but not Spanish.
Yeah, okay. French but not Spanish. French but not Spanish, I mean this region. French but not Spanish. We have x now 14. So 25 minus 14, 11. So this region contains 11.
So
And
it's
also,
11 over 30.
yes, because the probability, the number of students we choose from them over the total, so 11 over 30. Okay? Now, because x is 14, so the number at the middle is 14. And we can deduce that 18 minus 14, which is 4, so this region has 4 students. Next one.
A student who does not study Spanish is chosen at random. Find the probability that this student studies French.
Okay. A student who doesn't study Spanish. How many students doesn't study Spanish?
12. No. Yeah.
Yes, because all except this region. Okay? So 11 and 1. 11 and 1. So we have 12 in all. From those 12, find the probability that the student studies French. From this 12, how many students study French? Study French for?
11.
So 11 from 12, not 11 from 30. Because we choose from 12. A student who doesn't study Spanish is it chosen. So the denominator now, 12. Doesn't study Spanish, 11 and 1, so 12. How many one of them study French? 11. So 11 over 12. Okay? Now for B, this is related to the set. On the Venn diagram, shade the region R intersect B union Q not. Okay? B union Q not all the region around B and Q. All the region around B and Q. But I need the part which intersect with R. So I need this region only. So this is the answer. I need this region only. Because intersection, I mean the common between them.
Rooms in a hotel are numbers from 1 to 19. Rooms are allocated at random as guests arrive. This is the probability. What is the probability that the first guest to arrive is given a room which is a prime number? 1 is not a prime number.
Okay. So, how many rooms has a prime number? From 1 to 19. What is the prime numbers from 119 to 19?
2, 3, 5, 7, 11, 13, 17, and 19.
So, how many one of them?
There's 7.
8. We have 8.
Yes, sir.
So, 8 out of what?
19.
So 8 over 19. So what is the probability that the first guest to arrive is given a room which is a prime number? 8 over 19. The number of rooms which has a prime number over the total number of rooms. Now for B.
The first guest to arrive is given a room which is a prime number. What is the probability that the second guest to arrive is given a room which is a prime number?
Okay, so now we have the second guest. The first guest is given a room which is a prime. Okay? What is the probability that the second guest to arrive is given a room which is a prime number?
So it's 7 over 18.
Yes, because the number of prime numbers now 7. And the total, not 19. We have 18 rooms to choose. So 7 over 18. 21.
A teacher asks 36 students which musical instruments they play. P equals students who play the piano. G equals students who play the guitar. D equals students who play the drums. The Venn diagram shows the results. Find the value of X.
Okay, this X. We have 36 in all. So if we add all, the student should be get 36. So now we can add 2 plus 8 plus 1 plus 4 plus 5 plus 7 plus 5 and subtract from 36 to get X. So X equal what? So X equals 9. Now B.
A student is chosen at random. Find the probability that this student plays the drums but not the guitar.
Okay, drums but not the guitar. Drums but not the guitar. How many one of them?
12.
Yes, because we cancel this region. So I need 5 and 6. So 12. Okay. So 12 over what to find the probability?
12 over 36.
Over the total. Yes. 12 over 36. You can simplify, but we don't need to simplify. Now for double I, it plays
only two different instruments. So it's 11 over 36.
two different instruments. This region, or that one, or this one, okay? Because in this region, piano and guitar. This region, piano and guitar. But that region play all, okay? So this region, I'll change now. This region, piano and guitar. This region, piano and drums. This region, guitar and the drums. So we need to add all this number. 2 plus 5, 7. 7 plus 4, 11. But we cannot include 1 because this region, this one plays all piano and guitar and drums. Okay? So we have 11. Okay? So 11 over 36. 22.
Zara throws a ball 3 times at a target. Each time she throws the ball, the probability that she hits the target is 0.2. Calculate the probability that she does not hit the target in any of the 3 throws.
Okay. Probability that she does not hit the target equal what?
0.2.
0.8.
I'm sorry, sir, 0.8.
0.8 because 1 minus 0.2. This repeats 3 times for the 3 throws. So 0.8 and each one of them independent from the other. So 0.8 times 0.8 times 0.8. Because does not hit the target 3 times, 3 consecutive times. So 0.8 times 0.8 times 0.8.
1, 2.
0.5, 1, 2.
A gardener plants seeds from a packet of 25 seeds. 14 of the seeds will give red flowers and 11 will give yellow flowers. The gardener chooses 2 seeds at random. Write the missing probabilities on the tree diagram below.
Okay, so we need to complete the tree diagram. If the first red, so for the second to be red, 13 over 24, because the number of red decreased by 1 and the total decreased by 1. So now you can deduce the yellow. So the probability for yellow equal what?
11 over 24.
Yes, 11 over 24. Because we have in all, we have a 25. We have 14 red and 11 yellow. So for the first one to be red, 14 over 25. And for to be yellow, 11 over 25. If the first one is red, so the number of red decreased by 1 and the total decreased by 1, so 13 over 24. But the number of yellow is still 11, so 11 over 24. Now, what about this one? If the first one is yellow, so now, yes.
It is 14 over 24.
Yes, so the probability of red is 14 because we didn't take any of them. 14 over 24 and
10 over 24.
10 over 24 because we decrease the number of yellow by 1. If the first one is yellow, this means the number of yellow will be 10 and the total will be 24. So probability of yellow for the second one, 10 over 24, and for red, 14 over 24. Now for B.
What is the probability that the gardener chooses 2 seeds which will give 2 red flowers?
Okay. Red flower. So 2 red means red and red. This branch. So 14 over 25 times 13 over 24. So what's the answer?
91 over 300.
91 over 300?
Yes, sir.
Okay. For double I, 2 flowers of a different color. What is the probability that the 2 flowers of a different color? So this means red and yellow or yellow and red. Okay? So if red and yellow, this branch 14 over 25 times 11 over 24. Or means plus yellow and red, so 11 over 25 times 14 over 24. Or you can take one of them, then multiply by 2, because you have the same number. You have the same number. So what is the answer?
77 over 150.
77 over 150. 24.
In this question, give all your answers as fractions. The probability that it rains on Monday is 3 over 5. If it rains on Monday, the probability that it rains on Tuesday is 4 over 7. If it does not rain on Monday, the probability that it rains on Tuesday is 5 over 7. Complete the tree diagram.
Okay. So now we have Monday. The probability that it rains on Monday, 3 over 5. So this branch, 3 over 5. What about that one? No rain.
2 over 5.
2 over 5, because 1 minus 3 over 5. Okay. If it rains on Monday, so follow this branch, the probability that it rains on Tuesday, 4 over 7. So this 4 over 7. What about that one?
3 over 7.
So 3 over 7. Okay. If it does not rain on Monday, the probability that it rains on Tuesday, 5 over 7. 5 over 7. So this branch, the probability for this branch, 5 over 7. What about that one?
2 over 7.
2 over 7. After you complete the tree diagram, you can answer the question. Find the probability that it rains on both days.
It's 3 over 5 times 4 over 7.
Yes, 3 over 5 times 4 over 7. Yes, what is the answer?
12 over 35.
12 over 35. Okay. On Monday, but not on Tuesday. On Monday, rains on Monday, but not on Tuesday. So this branch.
So it's 3 over 5 times 3 over 7.
Times 3 over 7, which is?
9 over 35.
Now next, on only one of the 2 days. Only one of the 2 days. So rains, no rain, or no rain, rains. This branch and that one. Okay?
Yes.
So 3 over 5
Times 3 over 7.
times 3 over 7 plus
2 over 5
2 over 5
times 5 over 7.
times 5 over 7. So what is the answer?
So it's 19 over 35.
19 over 35. C, can you read C?
If it does not rain on Monday and it does not rain on Tuesday, the probability that it does not rain on Wednesday is 1 over 4. Calculate the probability that it rains on at least one of the 3 days.
At least one of the 3 days means 1 day or 2 days or 3 days.
Yes.
So 1 minus doesn't rain in any day. Okay?
Yes, sir.
1 minus doesn't rain in any day. So the probability that doesn't rain in any day, so this means no rain on Monday. So 3 over 5. Okay? No rain, so 2 over 5, sir. 2 over 5. No rain on Monday. And no rain on Tuesday, so 2 over 7. The probability that no rain, doesn't rain on Wednesday, 1 over 4. So 1 minus that answer. So at least 1, the probability that it rains, at least 1, this means 1 or 2 or 3. So 1 minus doesn't rain in all. So 1 minus probability of that it doesn't rain in any day. So 1 minus all that. Done?
Yes, sir. The answer is 34 over 35.
34 over 35.
Emily lost 2 blue buttons from his shirt. A bag of spare buttons contains 6 white buttons and 2 blue buttons. Emily takes 3 buttons out of the bag at random without replacement. Calculate the probability that all 3 buttons are white.
Okay. So we have 6 white and 2 blue, total 8. So Emily takes 3 buttons. So for the first button, the probability to be white, number of white over total. For the second button, because without replacement, so now you have 5 white and the total 7, so 5 over 7. For the third button, we have 4 white left and the total 6, so 4 over 6. So now multiply them. 5 over 14. Okay. I?
Exactly one of the 3 buttons is blue.
So 1 blue and 2 white. 1 blue and 2 white. So 1 blue, probability that 1 blue, this means number of blue over the total. If the first one is blue.
Yes.
Okay? So 2 over 8. Then, if the next one white, so this means 6 over 7 because the total now 7. And next also white, so we have 5 white and the total 6. But the problem, we have 3 cases because the blue can be the first one or the second one or the third one. And the order does matter in this case, okay? So we can multiply by 3 because we have 3 cases. The blue one can be the first, okay? Or second or third. This means like we have 3 cases, blue, white, white, or white, blue, white, or white, white, blue. All of them has the same probability. So we can find any one of them, then multiply by 3. Multiply by 3. Understood?
Yes, sir.
15 over
28.
28 in the simplest form.
There are 25 buttons in another bag. This bag contains the X blue buttons. 2 buttons are taken at random without replacement. The probability that they are both blue is 7 over 100. Show that x squared minus x minus 42 equals 0.
Okay. The probability that, 2 buttons are taken at random without replacement. The probability that they are both blue, 7 over 100. We have x blue and the total 25. What is the probability that the first will be blue? Isn't the number of blue, which is x, over the total 25? If the second button is blue,
X minus 1 over 24.
yes, x minus 1 over 24. Now if we multiply them, we have 7 over 100. Okay?
Yes, sir.
Now we can multiply numerator times numerator and denominator times denominator. X times x minus 1, x times x equal x squared. X times 1, negative 1 is negative x. 25 times 24, 600. This equals 7 over 100. Am I right?
Yes, sir.
Now we can cancel these zeros. This is easier. And cross multiply. We get x squared minus x times 1, which is x squared minus x. And the 7 times 6 is 42. Now transpose 42 to the other side. Now you have x squared minus x minus 42 equals 0. Okay? Now we need to factorize x squared minus x minus 42. You can factorize using calculator or without. X squared, x times x. We need 2 numbers. If you multiply, you get 42, and the difference between them, negative 1. So negative 6, negative 7, and positive 6. If you multiply them, you get negative 42, and if you add, you get negative 1. Or you can use calculator to factorize. Using mode 5.3, you can get the answer. If you use mode 5.3 and enter A and B and C, the coefficient of x squared and x and the absolute term, you get x equal 7 and x equal negative 6. Then you can take the 7 to the other side, so x minus 7, and negative 6 to the other side, so x plus 6. This is the two bracket using your calculator. To solve this equation, we have two brackets. Maybe this bracket equals 0. This means x equal transpose negative 7 to the other side, so x equals 7, or that bracket equals 0, so x plus 6 equals 0, so x equal transpose negative 6 to the other side by negative, so x equal negative 6. Now write down the number of buttons in the bag which are not blue. We have x now, but we have two values for x. X, the number of blue buttons. So the number of blue buttons can be negative?
No.
So this is rejected. So the number of blue should be 7. So not blue equals what?
25 minus 7.
Which is 18. Okay? Done?
When Ivan goes to school in winter, the probability that he wears a hat is 5 over 8. If he wears a hat, the probability that he wears a scarf is 2 over 3. If he does not wear a hat, the probability that he wears a scarf is 1 over 6. Complete the tree diagram.
Okay. Can you read the first line again?
When Ivan goes to school in winter, the probability that he wears a hat is 5 over 8.
So this branch, 5 over 8. So we can deduce that one?
3 over 8.
3 over 8, okay. Now go ahead.
If he wears a hat, the probability that he wears a scarf is 2 over 3.
So go ahead for this one. So this 2 over 3. So now the next one?
1 over 3.
Okay. If he doesn't wear a hat?
The probability that he wears a scarf is 1 over 6.
So this 1 over 6?
So the other one is 5 over 6.
Is 5 over 6. Now we can solve the question related. Now for B.
Find the probability that Ivan does not wear a hat and does not wear a scarf.
Okay. No hat, no scarf.
3 over 8 times 5 over 6.
3 over 8 times 5 over 6. You don't need to simplify, so you can write 15 over 48. Now, wears a hat but doesn't wear a scarf. A hat but no scarf.
5 over 8 times 1 over 3.
5 over 8 times 1 over 3, which is 5 over 24.
Yes, sir.
Okay. Now, wears a hat or a scarf but not both. A hat or a scarf but not both.
So it's 5 over 8 times 1 over 3 plus 3 over 8 times 1 over 6.
Yes. Wear a hat or a scarf, okay? But not both. So hat and no scarf, or no hat and scarf. So 5 over 8 times 1 over 3 plus 3 over 8 times 1 over 6 equal 13 over 48. Now see, if Ivan wears a hat and a scarf, the probability that he wears gloves is 7 over 10. Calculate the probability that Ivan doesn't wear all three of hat, scarf, and the gloves. So 1 minus wear all the three. Probability to wear hat and probability to wear hat and scarf. So 5 over 8. Probability to wear hat and probability to wear scarf 2 over 3. So if we continue with this branch, probability to wear gloves is 7 over 10. 7 over 10. So probability to wear all 5 over 8 times 2 over 3 times 7 over 10. So 1 minus that branch. 1 minus 5 over 8 times 2 over 3 times 7 over 10, which is 17 over 24. Number 27. Pretty picks a card at random from the 11 cards above and doesn't replace it. She then picks a second card at random and doesn't replace it. Find the probability that she picks the letter L and then the letter G. So how many L do we have? We have N one time. So probability of getting L 1 over 11. Now we have, after we pick letter L, we have 10 letters left. I need the second letter to be G. How many G do we have? We have 1. So 1 over 10. Because we choose 1 from 10. So if you multiply 1 over 110. Now for double I, the letter E twice. We have E, we have 3 E's. So for the first letter, we can choose by 3 ways. So 3 over 11, because total 11. For the second letter, we have 2 ways to choose the letter E. So 2 over 10. Now the answer, 6 over 110. We can simplify or we can leave. For triple I, 2 letters that are the same. 2 letters that are the same. We have E 3 times and we have letter N 2 times. So the 2 letters may be 2 N's or 2 E's. If 2 E's, we did before, 3 over 11 times 2 over 10, which is 6 over 110. Or 2 N's, so 2 over 11 times 1 over 10. Then we can find the answer. 2 plus 6, 8, so 8 over 110. Now 28. If the weather is fine, the probability that Carlos is late arriving at school is 1 over 10. If the weather is not fine, the probability that he is late arriving at school is 1 over 3. The probability that the weather is fine on any day is 3 over 4. Complete the tree diagram. So if this tree, the probability that the weather to be fine, 3 over 4. So not fine, 1 minus 3 over 4. So 1 over 4. Now, if it is fine, arriving at school late, 1 over 10. So not late, 9 over 10. 9 over 10. If the weather is not fine, the probability that he is arriving late at school, 1 over 3. So this is 1 over 3, this is branch 1 over 3. So now this one, 2 over 3. Now we can solve the question. In a school term of 60 days, find the number of days the weather expected to be fine. The number expected to be fine. The weather expected to be fine. Expected number equals the probability to be fine times the number of days. Expected number, the probability times the total number. So, probability to be fine, 3 over 4. 3 over 4 multiplied by 60. So 45. So 45 days and 60 days. Find the probability that the weather is fine and Carlos is late arriving at school. Fine and late. So 3 over 4 times 1 over 10. 3 over 4 times 1 over 10, which is 3 over 40. Find the probability that Carlos is not late arriving at school. Not late, so this branch or that one. So fine and not late, or not fine and not late. So 3 over 4 times 9 over 10, or means plus 1 over 4 and 2 over 3. 1 over 120. Find the probability that the weather is not fine on at least one day in a school week of 5 days. Not fine at least one, so this means not fine 1 day or 2 days or 3 days or 4 days or 5 days. So 1 minus is fine in the 5 days. 1 minus the probability that the weather fine in all days in the 5 days. So 1 minus the probability that the weather is fine in all days in the 5 days. So 3 over 4 times 3 over 4 times 3 over 4, 5 times. So 3 over 4 power 5. So 1 minus 3 over 4 power 5. The answer 781 over 1024.